Hello everyone and welcome to ABG's Investor Days. My name is Carl Bokvist and I'm an industrial analyst here at ABG. With us now we have the pleasure of hosting Freemelt and the CEO Ulrik Ljungblad, and with us we also have the chairman Carl Palmstierna. The format will be as such that we will have an introductory presentation by Mr. Ljungblad, and after that we will have some questions and answers from my side as a moderator. But without further ado, Ulrik, thank you for joining us, and please, the floor is yours, as we say.
Thank you very much, and I'm very happy to have the opportunity to present here with ABG today. So I represent Freemelt AB. It's a startup company that's now maybe more in the scale-up phase, and I will talk about what we are and what we do. So please shift to the next slide. Freemelt is a company making 3D printers, advanced 3D printers, and our goal is to become a globally dominant and manufacturing company in this area. And this is a background slide showing the sort of the what we are really aiming at, and what we ultimately are aiming at is to compete with casting and forging, which are huge businesses dating back more than 6,000 years. And to do that, our mission is to develop advanced and robust 3D printers that compete with traditional manufacturing in productivity, but that it will be vastly superior in part quality for some applications. So this is our ultimate goal, but on the way there, we also have, of course, stepwise goals for the company. So please, next slide. The story of Freemelt starts in much from the story of Arcam, which was a company, or is a company in Gothenburg in 3D printing. And the founders of Freemelt all have their background from Arcam, including myself. I was there for 10 years. It's a 3D printing pioneer company founded in 1997. They delivered their first system to customers in 2003. Focusing on systems for implant manufacturing from 2007, and later expanded its business also into aerospace, selling in total hundreds of systems. The focus on aerospace led to the fact that it was bought by General Electric in 2017 for about 6 billion Swedish crowns. And today, Arcam, to that point, Arcam was the only supplier of electron beam 3D printers until we started the company in 2017 and started delivering systems to the market a bit later. So next slide, please. If we switch then to Freemelt, we have a great mix of very experienced professionals. So, but also now, as we grow, also some young, highly creative engineers. The team has grown from originally 6. We are now 27 employees with more than 100 years of experience in advanced 3D printing. It's a solid experience in development of industrial equipment and in materials, but also in open source solutions, which is one of the key things that we are that is something that we embrace very much. Then we have expertise in service, sales, and marketing. And the founders of Freemelt were behind a majority of all the filed patents at Arcam. Next slide, please. Here I will become a bit technical. Just to explain what differs us from GE Arcam in the technology. Our choice of technology is crucial for extremely high speed and accurate processing, and that choice is then based on the goal that you saw on the first slide, to become a dominant player and really compete with traditional manufacturing. We have what's called a Diode Electron Gun, which differs from Arcam, which can have a a very well-focused tight spot all the way up to the maximum beam power. And this is what really enables fast processing and the possibilities in the market. We also use metal powder, and our customers can use metal powder from any supplier. This is a strategy for opening up markets and making it possible for customers to have versatility in the supply chain. We also have developed unique imaging, backscatter imaging for sensing in order to have quality control in our systems. And we also have developed our unique recoater technology, just like we developed electron beam technology also. So we have started from scratch with the technology, looked at everything, and developed what we think will work for the markets that we address. So next slide, please. So now we have also, of course, a management team where we have employed 3 new people during this year. Those are the ones on the right. And I especially want to mention Peter Jane, which is Vice President of Sales. He comes from a long career in manufacturing companies and in 3D printing. And he came from us after a few years at Desktop Metal, which is the fastest growing company in the 3D printing business, an American startup that started a couple of years before us. Next slide, please. Freemelt started 2017. After 2 years, exactly after 2 years, we delivered the first system to our first customer, actually spot on time for what we promised to the investors back in February 2017. And Freemelt is now #1 choice for material development in 3D printing. So far, we are now installations in the double-digit numbers. We have, for instance, some of the most renowned institutes and universities in Europe. We have systems in Sweden, also at KTH, that we installed this year. But we also have systems with 2 large industrial companies that with their R&D departments that are very interested in material development for their applications. And our customers are developing many new materials. But there is also a strong interest from industry for a Freemelt production system with industrial applications in these new materials that are being developed. Next slide, please. So already from the start, we had a business strategy, which is a 2-step strategy. So we are going from R&D to commercial applications in close collaboration with customers and partners. We started by developing and bringing to market an open source research system, material research system called Freemelt One for development of new materials to push the need for an industrial manufacturing system. And as I pointed out on the previous slide, some of the most renowned R&D institutions are now customers to us, producing research results promoting our technology. So what we say now is that this first step in the business plan is implemented, and we are now moving into the second phase of the company development. So next slide, please. And the next phase then is the development of an industrial 3D printer optimized for volume production, with manufacturing processes also developed and core technology directly transferable from Freemelt One. So in this way, we are aiming to build an ecosystem with a new system and a research system where processes can be developed and transferred between the 2 systems. But in this ecosystem is also our customers and suppliers of raw material, the powder, but also software companies providing software solutions. So there is a unique timing right now of opportunity with GE Orcam increasingly focusing only on internal aerospace applications. They have fantastic success internally with turbine blades that they are building for their own aerospace engines, but not focusing on so much on their other customers. And with other competitors, it's still in early phase when it comes to competitors using electron beam technology. And we're also now collaborating with selected industrial partners through the development phase. So we are working together with them on defining requirement specification for this system in order to make sure that they fit into their factory. Next slide, please. So the Freemelt industrial system is to a large extent technically developed from the Freemelt 1 system. Key components for the industrial system already are fully developed and in use in Freemelt 1. We have just closed a collaboration agreement with an engineering company, Detta, for project excellence. So Detta will be our supplier of services when it comes to development, technology development. We have Detta is chosen for the reason that they are focusing. It's a service company that are focusing most on additive manufacturing. Is one of their focus areas. So we have management from Detta in the steering group of the project, which is important for the excellence of this project. We also have strategic partnerships now with a US company, 6K Additive, for supply of quality metal powders to us and to our customers. And these two products that will be in our product portfolio are completely different products addressing different markets. So we will continue to build and ship Freemelt 1 systems to targeting R&D markets, universities, research institutes, and also R&D departments in large companies. That's where we already have success. And just a rough estimate is that there should be about 1,000 research facilities as potential customers only in Europe, the same or probably even more in North America. So we do see a great potential in this market of continuing our efforts to expand with sales towards research and development. But then we will also then have a fully automated and efficient machine for production, targeting large verticals. And we have selected, after a business study, we have selected 3 target materials where we are developing material processes for this system. One is orthopedic implants in titanium. One is components in copper, mainly for electrical vehicles. And the third one is components in tungsten for medical equipment and the nuclear industry. All of these verticals are multi-billion-dollar industrial markets. Next slide, please. First, I will talk about business case titanium orthopedic implants. Next slide. So this is the area where 3D printing has had the most success, actually. There is about somewhere 3 to 4% of all implants in the world are manufactured today with 3D printing. The reasons for that are that it's a big advantage, both from lifetime in the body and also with the adherence to the bone, with the net structures that can be built directly in the same process step that enables bone ingrowth into the metal part. And the total implant market in 2018 was $51 billion, mainly in joint replacement. Knees were the biggest part, just followed slightly behind by hip implants, and then other extremity, and then other implants. And we are focusing initially on hip and other extremity parts like ankles and shoulders. The 3D printing growth in this market, so the growth of the market in total is about 3.5% worldwide, but the market share of 3D printing grows much faster than that. So it's expected that 3D printing will be the dominant technology in the future for implant manufacturing. So here is a huge market for us to address with a material, titanium, that works really, really well with electron beam technology. Next slide, please. The next market that we're addressing is ultra pure copper parts. most of these applications are towards electromobility in some sense, which is, of course, also something that is growing fast. And the reason why we are so keen on ultra-pure copper is basically what you see on the right. There is a high absorption of beam power with electron beam, which is not at all the case with our competitors using laser beams. There is more than 90% reflectivity, and this leads to very slow processing with those machines. While for us, we can have a high productivity, leading to production cases. And the other is that we are working with a vacuum technology. The processing takes place in vacuum. That means that we can have an extremely clean environment, which benefits the ultra pure processing of copper, which is very important because going from pure to ultra pure copper raises the conductivity of copper with up to 30%, which is, of course, crucial for things like battery technology and electric drives and so on. So here we see a very big potential for electron beam. There's also been a number of case studies with electron beam systems when it comes to copper research on 3D printing with pure copper. So next slide, please. The third and the last market that we are initially addressing is parts made of tungsten. This is probably a little bit smaller, but still big applications. We are in a case study in this area for medical equipment. That is what you see on the top picture. This is what's called a scatter grid for CT scan equipment, which is a good and good size market for us, and also for the reason that also here the electron beam technology has strong advantages over our competitors. There are no cracks in finished parts when we build bulky parts. This is not achievable with low temperature processing as are used by our competitors. It's also easy to melt with electron beam despite the very high melting temperature of tungsten. Tungsten has the highest melting temperature of all the materials in the periodic table. But we also see some other applications going forward with this in aerospace, balance weights in aerospace and vehicles, for instance, but also especially temperature and radiation shields in power plants. Okay, next slide. Finally, some financial information and event history through the years that Freemelt has existed. We started in 2017 in February. We had investment from private investors. The first year we had a modest revenue and not so good result, of course. 2018 we had new investments from other private investors, raising the revenue a bit, and we had a better result that year. 2019 was a good year. We had investment by Industrifonden that year, and the revenue was much higher. It's about almost 20 million Swedish crowns. We even had a slightly positive result that year. 2020 was a very tough year with COVID. Our main market, the universities, they basically locked up and went home and worked from home, and there were very few investments done. So we had measures to mitigate against that, but we still managed to have a revenue of about 18 million Swedish crowns that year, but with a worse result than the previous year then. This year we had a pre-IPO investment in the company of 85 million crowns at a pre-money valuation of 281 million. And we performed a listing on Nasdaq First North Growth Market on the 7th of July. And so now our reports are, of course, public, and our first report, the Q3 report, we had up till the revenue this year until that report is 16.5 million crowns with a negative result. So next slide, please. Finally, summary. Freemelt has developed a new high-power electron beam 3D printing technology for more productive 3D printing than laser powder bed fusion, and also existing electron beam powder fed fusion. On the market, we are on the market with customers using the technology since actually more than 2 years back for material development. We are now taking the next step in commercializing our technology by developing an industrial Freemelt system. We are now half a year into that project where we have been working with requirement specifications and are now moving into the design phase. We embrace open source for fast scaling. This is important because it's not only opens up for using software and for the customers to use the machine in a more versatile way. It also makes it possible for our customers to create their own IP, which is and also that they can have full knowledge about the system, which is important in regulatory markets like for instance implants. And the expansion is predicted by sales in selected market verticals that I just presented. We were on the 33 list last year from New Technique, for instance. Next slide. So thank you very much.
Thank you, Ulrik. And with a bit of time left, my question is just on the potential revenue model, if you could elaborate upon that when you know, one part in Freemelt 1 and the second one is the potential revenue model in the industrial printer when it comes to, you know, the go-to-market strategy, potential price points. Is it an initial selling price and then a license fee? So how do you aim to capitalize on your technology?
Right. So like I said, we are still going to consider the R&D market as a key market, but it will not be the biggest of our markets in the future. But it's a good income, but especially because it promotes the development of new materials. Often the material development are done by industrial companies together with the institutes and universities, and that means that if we have our technology there, it will promote the business that is our main target, that is the industrial side. So we will continue to have revenue from Freemelt 1, but of course going forward in the future, the main focus for Freemelt is multiple sales into factories primarily in the verticals that you saw, but of course in the long run in new verticals as they appear. The price point for an industrial system will be higher than the research system, and we will also work with licensing on software that we develop and with processes. So, but we are not planning to do like some companies in this business do, and that is to source the powder. We want to have an open sourcing strategy for software from a continuously growing 3D printing industry, but also that the customers can develop and choose the supplier of metal powder also more freely than our competitors. And also the industrial system will be mainly an open source software system.
And I realize we're approaching the end here, but my final just quick question is just on the technology and the components that you use when it comes to the cathodes, anodes, the vacuum technology and everything. How much do you manufacture in-house and how much do you source from other suppliers?
Yeah, so we have a number of suppliers, and we source vacuum technology, for instance, from existing from the market. But when it comes to the cathode and anode, that was a surprisingly specific question. That of course we design and manufacture the mechanical parts in mechanical workshop where we purchase that. They are custom made, and so by drawing. Actually, for the cathode itself, we have that's one of the very core parts of the system. We have developed our own technology completely, and we are still manufacturing the cathodes in-house. Actually, this is also a strategy that the very core of our technology we want to keep internal, both when it comes to manufacturing and knowledge. And this is also where we apply for patents. We have currently 11 patent applications in, out of which one has now been accepted as a full patent in the US, and we expect many more to follow.
Understood. With that, I believe our time is up. Ulrik, thank you so much for joining us. Thank you, Freemelt. And for you, those of you who have been watching, stay tuned for our next presenting company. Thank you.
Thank you very much for the opportunity. Thank you.